Hello and welcome to this video about use case 7 of Values project, human-robot collaboration in a disassembly process with workers with disabilities. My name is Íñigo Olguea and I'm a researcher in the Research and Development Department of Electrotechnical ABESA, a company mainly dedicated to the development of electrical engineering, automation and robotic solutions, which is partner of the Values Consortium and provider of this use case. As most of you already know, the Values project is a European Horizon 2020 project that involves industrial partners from various domains, research technology organizations and universities, and that its main objective is to design, implement and evaluate state-of-the-art methods and tools that reduce the time and cost needed to verify and validate automated systems with respect to safety and security requirements. Especially, this goal is highly related to the use case 7, which will be described next, where a collaborative robotic cell for disassembly will be developed, and due to its use with workers who had some kind of disability, its safety requirements will have to be even more demanding. Focusing on the use case as such, waste electrical and electronic equipment represents the fastest growing type of waste in Europe. The increasing levels of electronic waste, inappropriate elimination, and insecure treatment pose significant risks to the environment and human health. Over the last decades, the ever-high amount of waste electrical and electronic equipment has become a significant problem worldwide. To reduce the impact of this problem, one of the solutions may be the treatment of end-of-life products. Responsible treatment of end-of-life products can include reusing, recycling, or remanufacturing. These processes can be both environmentally and economically beneficial, since waste is minimized while valuable components and materials are recovered. Manufacturing, in particular, is an emerging field due to its contribution to the growth of greener manufacturing industries. This process is defined as a series of procedures that allow products and parts that have reached the end of their useful life to be marketed as new products. One of these procedures is disassembly. This procedure involves the removal and segregation of parts, pieces, or materials designed for future repair and maintenance of the electrical and electronic equipment, and is usually carried out in specialized plants. Ecointegra is one of these plants. Located in the north of Spain, in addition to waste management, out of 40 people employed by the organization, 90% of the staff are people with some kind of disability. Thus, it not only promotes the circular economy, but also social inclusion. One of the dismantling processes performed by the company is the disassembly of refrigerators. To disassemble these household appliances, once the drawers and shelves have been removed from the interior, the magnetic gasket attached to the door, which allows the door to close hermetically, must be taken off. This task is currently performed manually. The workers use a screwdriver to pry the gasket open at one of the corners and pull it out. Notwithstanding, both the state in which the company received the refrigerators and the form in which the gaskets themselves are found not only makes the extraction a tedious task, but in the long term, the effort made by the workers in uncomfortable and unnatural postures to remove them can lead to musculoskeletal disorders. Therefore, due to these issues, it is desired to automate this task. To this end, Use Case 7 will develop a collaborative robotic cell that will extract the magnetic gasket while preserving the safety of the worker. To do so, the robotic solution will have vision, a voice manager, and will apply artificial intelligence techniques to perform the task. However, since this cell will work together with staff with disabilities, the system will have to meet certain requirements in terms of safety as well as performance. For this purpose, 9 requirements divided into 4 evaluation scenarios have been defined and will be verified and validated through the respective test cases. Taking as a starting point the ISO 10218 standard, which establishes the safety requirements for industrial robots, as well as the ISO 15066 standard aimed at collaborative robots. Specifically, these are the requirements to be met by the robotic solution to be developed. On the one hand, it must allow hand guiding, monitor the position of the worker with respect to the robot within the workspace, and provide half a meter of clearance between the robot and the different structures so that there is no possibility of entrapment. On the other hand, it must have a high rate of recognition of voice commands, despite the possible diction problems that workers may have. Also, if the robot is being controlled by an external device, such as the voice manager, it will not be able to respond to commands sent from another source. It will perform a safety stop in the event of a loss of connection and will have established physical safety limits that will not be violated despite manual or voice control. And finally, it will have to meet a final performance requirement associated with the artificial intelligence, where the reinforcement learning will be used to extract the magnetic casket from the fridge. As mentioned before, these requirements will be verified and validated through the respective test cases. For this purpose, Use Case 7 will make use of 3 verification and validation methods: simulation-based testing for human-robot collaboration, test optimization for simulation-based testing of automated systems, and virtual and augmented reality-based user interaction V&V and technology acceptability. These methods will be worked on together with our use case partners, Mondragón Goya Politécnicoa and Universidad de Castilla-La Mancha. Thus, at the end of the project, a collaborative robotic cell for disassembly will have been verified and validated in a simulation environment, and its acceptance among users will have been studied by means of augmented reality techniques. Likewise, for those requirements that cannot be completely verified and validated in a simulation environment due to the possible reality gap that may exist due to the use of artificial intelligence techniques, the option of carrying out these tests in the real world will be considered. So thank you very much for your attention. In case you have any questions or interest, please do not hesitate to contact me via the mail address below. And please don't forget to follow the Values project on the different social networks to keep updated on the news of the project. Thank you very much.